Right, section 2.7 is solving proportions. We're going to continue to set up rates and ratios, but this time we're going to have a proportion which will help us solve for missing quantities. So first thing that I have for you is the definition of what a proportion is. It is an equation that states that two ratios are equal. And I have an example there, 1/2 equals 2/4. And I think this is something we're all very comfortable with. If we reduce 2/4, you know that that equals 1/2. So that statement right there with fractions on both sides or ratios on both sides with the equal sign, that is a proportion. Okay? We are going to solve proportions, and there's a couple methods. And this first method is using multiplication. So looking at the example, 7/8 equals m over 12. We can solve this just as if it was a two-step equation, or excuse me, a one-step equation. The side with our variable, it is being divided by 12. So then, using our inverse operations, we could multiply both sides by 12. So then when I do so, my 12's cancel. On the left-hand side, I can cross-cancel my 8 and 12. I can divide both of those by 4, just to help simplify things. And then I can multiply, and I get m equals 21 over 2. You could also write this as a mixed number, which would be 10 and 1/2. Okay, so that's the first method that you can use. Honestly, we're not going to spend a lot of time looking at this method. The second method here is one that we're going to use more often, and that is cross products. Cross products, this is the product of the diagonal when comparing ratios. Okay? So let's relook at that example that we just did by multiplying both sides by 12. So 7/8 equals m over 12. Using cross products, we can also solve for m. And we're going to go on a diagonal. So 7 times 12 is going to be the left-hand side. So just start at one numerator, multiply it by the opposite denominator, and then do the same thing with the other numerator. So we have 7 times 12, and now we have 8 times m, and all you need to do now is bring down that equal sign. Okay? And now, just by using inverse operations, we can solve for m. So by simplifying, multiplying both sides, we have 84 equals 8m. Now we can divide both sides by 8. When we do so, kind of skipping ahead with the simplifying, we're still going to get that 21 halves is going to equal m. Both methods would work, and especially when we're looking at a simple example like this, that multiplication may work better, but we are going to get into more complex methods, or excuse me, complex problems. So let's look at a second example using cross products. So b minus 8 all over 5 equals b plus 3 all over 4. Notice on this example that in our numerators we have more than one term. We're going to use cross products again. So we need to multiply b minus 8 times 4. Notice how I have that written. I have a 4, then parentheses with b minus 8 inside. You need to take the 4 times everything that is in that numerator. So we're going to eventually have to use the distributive property. So be careful. Make sure you just don't take 4 times one of those terms. It needs to be by both. Same thing on the next piece. We need to take 5 times everything in that numerator. So we're going to set that up using parentheses. Now, next step would be distributing. So if we distribute that 4, we get 4b minus 32 equals, and then now distribute that 5b plus 15. Okay. Just using our steps for solving equations, we can subtract 4b from both sides. When we do so, we get negative 32 equals b plus 15. Next, we can subtract 15 from both sides, and then we find that b equals negative 47. Okay? So there's an example where cross products may be the better method. I do want to include one word problem, which would be more of the application. And then this will be the last example for your notes on this section. A florist is making centerpieces. He uses 2 dozen roses for every 5 centerpieces. How many dozens of roses will he need to make 20 centerpieces? Well, first off, when we're setting up a proportion, backtrack. When we solve this, we want to set up a proportion. We know 2 dozen roses will give us 5 centerpieces. So I'm just going to write that that would be a rate. We have 2 separate units. So we have 2 dozen gives us 5 centerpieces. We need to set up another rate on the other side of our proportion. We know that we need to have 20 centerpieces. So notice where I put the labels. I put all centerpieces in the denominator. You could put all centerpieces in the numerator, that would be just fine, but it does need to be consistent. So as you're looking across the denominator, it needs to be the same unit. As you look across the numerator, it needs to be the same unit as well. And the question asks us to find how many dozens of roses will we need. So since we don't know that, choose a variable. I chose X, and then I put in the word dozens. That's what I'm solving for. And I'm keeping that, I wrote that label in so I could look across my numerators and make sure it was consistent. So now that it is set up, I can use the cross products. So I need to multiply across. 2 times 20 equals 5 times X. And doing some simplifying, I get 40 equals 5X. Divide both sides by 5. Get 8 equals X. So caution, reminder, when you are writing your answer to a word problem or anything that has labels, your answer needs to have labels. So I did not stop at 8 equals X as my answer. My answer is 8 dozens of roses. That's what the question asks, how many dozens of roses are needed. Okay? Hopefully you find this section very easy. Other than that, that is section 2.7.